Okay, in this video we're going to be working on some problems for mechanical advantage and then breaking strength of wires. Okay, we're going to end up using these formulas right here. They're on the first sheet of the packet that I gave you in class. Okay, so we're going to be using this APR formula, which is the formula for actual power required. Okay, we're going to be using this formula here for AMA, which is the actual mechanical advantage. And then later on, we're going to use these two here. Okay. We're also going to have to calculate the theoretical mechanical advantage. All right. Anyway, I'll be showing you how to do all these formulas here. All right, step by step. So in your homework or in your work packets, all right, we already gave you the problems and there was the solution there. What I'm going to do is I'm going to work you through these problems step by step, though. Okay, so we've got a double luff tackle rig to a disadvantage. All right, we want to lift 300 pounds with that. All right, so how much are we actually going to have to pull, okay, in order to lift that weight? So what's the actual power going to be required? And then what's the actual mechanical advantage? So we're going to do this problem in a few steps, okay? So the first step we want to do here is, well, let's figure out what kind of tackle we're using. We're using a double luff. So a luff tackle means that there's the bottom block and the lower block. The two blocks have different number of shivs. So a double luff is going to have 3 shivs in one block and 2 in another. Okay, so that would look like maybe something like this. Okay, so that's telling me there's 5 shivs there. Okay, and is it rigged to advantage or disadvantage? It's rigged to disadvantage. Okay, which means that it's pulling off the top. This little picture is going to be useful to me. Okay, because what I need to do here is I need to figure out how many shivs. I need to figure out the theoretical mechanical advantage, okay? Then I'm going to need to figure out my actual power required. And then fourthly, I'm going to figure out what the actual mechanical advantage is, okay? So this picture right here of the block and tackle system helps me answer these 2 questions. The number of shivs, well, double luff, that's 3 and 2. That's going to equal 5. And the theoretical mechanical advantage, okay, is going to be, you count up the number of shivs, okay, so it's either going to be a 5 to 1 if it's to disadvantage, or a 6 to 1 if it's to advantage. So I've got 1, 2, 3, 4, 5, okay, it's to disadvantage, so that means that my theoretical mechanical advantage is 5. If this had been rigged to advantage, I would have put this this little thing here on the bottom block, and then I would have said 1, 2, 3, 4, 5, 6. Okay, but it's not. Okay, so now we've done that. Now we got to do APR. So we need our formula there that we used from before. Okay, and our formula. Okay, now I'm going to do. So that was step 1, step 2. Now I'm going to do step 3. So the formula is APR. Okay, actual power required. And if you look directly at that formula sheet, what it's going to say is that is equal to the weight times 1 plus 1 times the number of shivs, okay? Shiv number, and that's all divided by TMA, okay? Now this 1, if you're going to lift, what are we lifting here, 300 pounds? You have to lift all of the weight of 300 pounds, okay? That's 300 pounds. That's what that 1 is there for. But then each one of these shivs is going to add 10%. All right, so 10% of 300 is 30. So 30, 60, 90. Anyway, I'm going to have to add another 150 pounds. Okay, so that's what the formula does. But there's actually somewhat of an easier way to do this. Okay, basically what you can do is you can say that the APR is equal to 1. Okay, all right, point, and then you just put the number of shivs in there. 1, 2, 3, 4, 5. 1.5. Okay, well, oh, wait a second. We've got to put the weight in there first. APR is equal to the weight, which is 300, times 1 point, and then just count up the shifts, 1, 2, 3, 4, 5. Okay? And then we're going to divide that all by the theoretical mechanical advantage, which was also 5. Okay? When we do that math, 300 times 1.5, that comes up to here. That gives me 450 over 5, okay, which is equal to 90, okay? That's the actual weight, okay? The actual power required. I got to lift 90 pounds, okay? So, using that block and tackle system with this number of shivs and that weight, I can, when I pull, I only have to pull with 90 pounds to lift 300 pounds. Well, now the question becomes, what's that actual mechanical advantage? So that's where we're going to do step 4. We've done 1, 2, and 3. Now we're going to do step 4. Okay, so step 4, AMA, okay, actual mechanical advantage is the weight divided by the APR. That's what we just calculated. Well, what's our weight? It's 300. Our APR is 90, okay, right? That's what's going on here. And when I do that, when I divide 300 by 90, I'm going to get 3.3 to 1. Okay, that's the actual mechanical advantage. All right, so that's step by step doing that problem. All right, let's do another one. All right, now we're going to do problem 3 on this same handout here. Okay, so it's the same thing, it's the same basic problem. All right, what are we going to do? First, we've got to figure out how many sheaves we've got. We also have to figure out what our theoretical mechanical advantage is. Oh, excuse me, let me get that over here. Okay, we got to figure out how many sheaves we got. We got to figure out what our theoretical mechanical advantage is. Okay, then we're going to calculate our APR, and then we're going to calculate our AMA. Okay, so step 1, let's draw a picture here. You're using a runner. Okay, a runner. All right, so what's a runner look like? Okay, there's a runner and a whip. Those both have 1 block, 1 shiv. Turns out the runner, the block is this is what a runner looks like. Okay, all right. So here's the block here. Okay, so with a runner, the number of shivs is 1. The theoretical mechanical advantage of it though is 2. Okay, so now we're ready to move on to step 3, which is the APR. So 3, our APR is going to equal the weight times 1 point something over TMA, okay? And that something is going to be the number of shivs. So APR equals weight, which is 100, times 1 point, how many shivs? 2, over TMA. TMA was 2, okay? Oh, excuse me, our number of shivs was 1, not 2, I'm sorry, okay? Our number of shivs was 1. So that's where this came from, 100 times 1.1 divided by 2. Okay, when I do that, that's going to give me an APR is equal to 55 pounds. Okay, all right, great. Okay, now that was step 3. Now I'm going to do step 4. Well, if I am using 55 pounds of force to lift 100 pounds, what is my actual mechanical advantage? All right, so now we're going to do step 4. AMA is equal to, the formula for that is the weight over the actual power required. So our weight is 100 pounds divided by 55 pounds, okay, and that's what's happening right here, okay, and that is 1.8 to 1, okay. So those are the only 2 problems I'm going to do on this particular thing. That's what we went over in class. All right, now the next problem that we're going to take a look at is on this sheet here. Okay, it's called 241 week 9 day 1, and there's problem 1 and problem 2. Now problem 1 is just like the problems we just did. So what I want to do is I want to do problem 2, this one right here. And I've got a clean sheet right here. Okay. So we're going to do this problem, all right? And this problem is a little bit more involved than the previous problem. All right, so we're hauling up an accommodation ladder. So before we even do that, let me just draw a little picture for what that is. Here's your vessel. All right, accommodation ladder is typically the ladder that the pilot uses to get on and off. It's what we use when we're underway. So it comes down the side of the ship, and there's a platform there, and it's attached to the ship here. And then there's a davit, and you have a block and tackle system. Okay, and that block and tackle system is supporting this end of it, all right, and the other end is supported by the other end. So what it boils down to is that half the weight is being supported here, and half the weight is being supported by the block and tackle. So right off the bat, whatever the weight is of the ladder, we're only going to be lifting half of it with this end, all right? So that's something we're going to have to deal with. The other thing is that at the end, they want to know what the breaking strength of the wire. So we're going to have to go back to our old what is the required braking strength in long tons? Okay, so we're going to have to do that. They tell us the safety factor is a 6. Okay, we know that. The other thing that's interesting here is that they're giving us the weight in pounds, but they want the answer in long tons. So we're going to have to do a conversion there too. Okay, so we're going to do this in a number of steps. First step is we're going to figure out the actual weight we've got to lift. Okay. All right, and then after we do that, then we need to know what are we lifting with. Okay, we're lifting with our block and tackle system. So what's our shiv number? All right, we got to know what our theoretical mechanical advantage is. Okay, we got to calculate that. After we do that, then we're going to do our APR. Okay, and after we do that, they're not asking us for the actual mechanical advantage. Then we got to do braking strength. Okay, so we're going to do all these steps. So what's the weight? So step 1, it's 1,000 pounds, okay, but we're dividing it between 2, so that means that we're actually lifting 500 pounds, okay? 500 pounds is going to be lifted by the davit. That's great. Okay, so now we got to figure out our shiv number. Okay, so a double luff. Let's see, what is that we're looking at? We're using a double luff. So a luff has an unequal number of shivs in the top and bottom. So a double luff is going to have 3 in the top or 3 in the bottom and 2. Okay, anyway, we're going to have 5 shivs in the block and tackle. And it says that there's an additional block somewhere on the davit, all right? So there's probably, anyway, this is, another. So there's going to be an extra shiv as well. That's crazy. All right, but that's just to give a better lead to the deck winch. Instead of you hauling on that, you're going to lead that down to the deck winch, and you're going to use that power. So you've got 5 shivs in the block and tackle, plus an extra shiv to fair lead the load to the thing. So we've got to have 6 shivs. Now let's figure out our mechanical advantage. It's rigged to advantage, so we're pulling off there. Okay, so how many, what's our mechanical advantage then? It's 1, 2, 3, 4, 5, 6. All right, so our shiv number equals 6, and our mechanical advantage also equals 6. Okay, great, now we're ready to go. So let's do our APR now, okay? So our APR, I'm going to come over here, all right, 4. Our APR is going to equal the weight times 1 point, and we're going to just put the total number of shivs, I could just say SN here, divided by TMA, okay? So that's going to equal the weight. What is our weight? It's 500 pounds, okay, times 1 point. Our shiv number was 1, 2, 3, 4, 5, 6, okay, divided by our theoretical mechanical advantage, 6. So you can see now that that is essentially this part of the formula right here, okay? So when I do my little math here, 500 times 1.6 is going to equal 800, all right? When I divide that by 6, I get 133.33. That's pounds, okay? All right, very good. Okay, now, what we got to do now is we got to do step 5, okay? I guess actually they are asking for the actual mechanical advantage, so let's do that now, okay? So 5 are, I'll do here 4B, okay? 4B, actual mechanical advantage, that's going to be the weight divided by the APR, Okay, so what is our weight? All right, our weight is 500, and our APR is 133.3. Okay, so anyway, when you do all that, that works out to 3.75 to 1. Okay, that's the AMA, all right? And that's right there in this step right here. So the final step now is going to be the braking strength. So our braking strength is equal to safe working load times safety factor, okay? So our safe working load is actually just going to be the weight of the, it's our actual working load. It's the weight that we're lifting with the block and tackle, okay? So our safe working load is 133.33 times safety factor. Well, they told us in the problem that safety factor was 6. So I'm going to use that times 6. All right, and that's being done right here, and that equals 800 pounds. Okay, 800 pounds. Now we would be done, except the question is, what is the braking strength in long tons? So I have to do one more step. I have to convert pounds to long tons. All right, this is the last step. So what I'm going to do here is I'm going to take this and I'm going to multiply it times 1 ton for every 2240 pounds. Okay, the pounds disappear and I'm left with tons. And so essentially what I'm doing is I'm dividing 800 by 2240, and when I do that, I get 0.36 tons. Okay, so that's that problem. All right, and we're done with that one now. Okay. All right. So the next problem we're going to do is more complicated. We're going to this sheet here, Seamanship NS241, and here's problem 1. All right. Now, what I've done is I've just this is problem 2 is right there on your sheet, but I got rid of that so that I could do this problem in front of you. This is a multi-step problem as well. Okay. Again, we got to find braking strength. We're using a wire. It's a lifeboat. It weighs 5 tons, rated for 80 people. Each person weighs 150. So we've got a weight of the boat, plus we've got the weight of all those people. That's going to be our total weight. The lifeboat is suspended by 2 gun tackles rigged to disadvantage. Okay, so we've got to figure out shiv number and all that stuff, but it's being suspended by 2 tackles, which means each tackle is holding half the weight. Okay, so after we do that, then we can figure out the rest of the problem. So this is going to be the steps we're going to do. Step 1. Okay, we got to figure out the actual weight. All right, and step 2. This is the weight total. Okay, then we got to figure out the weight per tackle. Okay, which is essentially we're going to take the total weight and divide that by 2. Okay, and then we got to figure out our shiv number. We've got to figure out our theoretical mechanical advantage. Okay, and we're going to draw a picture to get both of those. All right, and then we're going to do our APR. Okay, and then finally we're going to do our braking strength. Okay, so many steps here to get to the end, and we're going to use multiple formulas to do that. So let's just, and these are the steps, but I'm just going to go ahead and work through them one by one. Okay, so 1, the total weight. All right, so we have, for people, we have 80 people times 150 pounds, and when you do that, you get 12,000 pounds. Okay, and then the boat, that is 5 tons, and what I'm going to do is I'm going to multiply that by 2240 pounds per ton, okay, and tons go away, and that gives me a total of 11,200 pounds. So my total weight is going to be 23,200 pounds, okay? And that is essentially how we got to this step there. Okay, so now we're going to do step 2, which is the weight per tackle. So that's our total weight, which is 23200 pounds. okay, divided by 2. So our weight per tackle, all right, is going to be, when you do that, it should come out to 11,600 pounds per block and tackle. Okay, great. So now I'm ready to figure out my shiv number. Okay, so what do I have? I have a gun tackle. So gun tackles are, here's step 3, okay? Gun tackle, there is a shiv in the top and a shiv in the bottom. So I've got 2 shivs, okay? Now, is it rigged to advantage or disadvantage? It's rigged to disadvantage, so I'm pulling off the top. So my shiv number equals 2, and my theoretical mechanical advantage, well, I just count up my number of shivs, that equals 2. So my shiv number is 2, my theoretical mechanical advantage is 2, all right? So now I'm ready to do step 5, which is my APR. So 5. So my APR is going to equal my weight times 1 point, and then whatever the shiv number is, okay, however many shivs divided by TMA. So what's my weight? Well, my weight is this, 11,600 times 1 point. Now, how many shivs? I calculated there were 2 shivs because it was a gun tackle, and there's no extra shivs in the system. And I also figured out that my mechanical advantage was equal to the number of shivs because it was disadvantage. So that's divided by 2. That's what's going on here. And that gives me 6,960 pounds, okay? That's the actual power that's going to be required when I'm pulling on that particular tackle, okay? Great. So now, what's the last step? The last step is to figure out the actual, the braking strength, okay? Braking strength, which is the safe working load, all right, times safety factor. Okay, now they tell us here that the safety factor is 6. So what's my braking strength? My braking strength is my safe working load, or my working load, which is 6,960 pounds times 6, okay? And that's what we have right here, all right? And when I do that, that's going to equal 41,760 pounds, all right? But they want the answer in long tons, I believe. Find the minimum braking strength for wire using London average. Okay, so well that would be the braking strength in pounds, right? But if I wanted it in long tons, I would multiply that by 1 ton for every 2240 pounds. All right, and I would end up with 18.6 tons. Okay, so that's that problem done. Okay? All right. Now, we're going to move on to this sheet. All right? And this is the next step. All right? And in this sheet, we are going to be using a different formula. So, the formulas we're going to use here are these two. I showed you these in class. C is the circumference, L is the load, okay, that's the weight being suspended. And then this 15 would be for Manila, okay. This would be for wire. You can see they've got different numbers here. And by the way, these formulas build in a safety factor of 6. So if I want to know what Manila size rope I should use to lift a particular ton, to lift a particular weight, I'm going to use this. L, by the way, is in tons. So if they give it to you in pounds, you have to convert it to tons before you stick it in here, okay? So let's do this first problem. What diameter Manila line is required to lift a half ton? Well, first of all, it's Manila line, so I'm going to use the Manila formula. So, but remember here, they're also asking for diameter. This formula is in circumference. So what am I going to have to do here? I got to figure out, 1, what's the weight, okay, in tons. 2, I'm going to use my formula for C for Manila. And then 3, I'm going to convert okay, to diameter, because this formula is going to give me the circumference, but the question's asking for diameter. So first of all, what is the weight in tons? So 1, it's a half-ton gangway, so W equals 0.5. Okay, great. So what's step 2? I'm going to use this formula. C equals L times 15, okay, and that's the square root of that. So that is, what's our L, okay? Our L is half a ton, so it's 0.5 times 15, okay? When you do that, you'll get, this is the intermediary steps, but C equals 2.74 inches. That's the circumference. But we don't want the circumference, we want the diameter. So now we're going to do 3. Circumference equals pi times d, which means now I have to figure out, if I want to get d, I got to divide both sides by pi, okay, to get d by itself. So d is c over pi, okay? So d equals, what's our c? 2.74 inches divided by 3.14, and that gives me a d of 0.8876 inches, which if you do a conversion ends up being about 7/8 inch wire. Okay? So that one's done. Let's do number 3. Okay? Find the minimum wire size to lift a 2.8 ton, oh, this one's already in tons, that's good, mooring block on a single part wire, a single wire that passes through a sheave, at the head of a small general utility crane. So this is a wire passing through one sheave. There's no mechanical advantage, but there is friction. There is friction, okay? So what are we going to have to do here, okay? We need to do a few steps here, all right? So what is our weight? Okay, 1, our weight in tons. All right, we're given that, okay? But we're going to have to figure out the power that's required, okay? We're going to have to figure out the power in this step. Then we're going to use our formula, okay? Our C formula, all right? C formula. And this time we're using it for wire. And then finally we're going to have to convert to diameter. Okay? So, what do we got here? We have a weight. So 1, our weight is 2.8. All right? And we're picking that up with a single block, mooring block, single part wire. Okay. So, our sheave number, all right, so for this next step here, 2, APR is going to equal the weight times 1 point, the sheave number, divided by TMA. So we need all that stuff. So what's our weight? All right, our weight is 2.8 tons. Our sheave number is, well, it's just one sheave, so that's 1.1. And what's our TMA? Is we're not getting anything, so that's 1 as well. Okay? So when we do that, when we multiply all that out, okay, we get 3.1 tons. So this means, this comes up here, APR equals 3.1 tons. Okay? Now we're going to use our C formula. So we're doing it for wire, though. So wire is a different formula than Manila. So C is going to equal to the square root of the load times 2.5. Okay? Well, what's our load? Here it is right here. So C is going to equal 3.1 times 2.5. Right? And that's what's going on right here. And that gives us a C of 2.78, okay, inches. Now the last step is we got to convert that to diameter. Okay, so this was step 3. Now we're going to do step 4. All right, so our diameter is, circumference is pi d. If I got to divide both, if I get d by itself, I got to divide both sides by pi. So that becomes d equals c over pi. Okay, and d equals c. What's that? That's 2.78 divided by 3.14. That gives me a D of 0.89, which is basically 1 inch. Okay? So that's that problem. All right? And we can take a look at this one too. All right? What are the steps we're going to do in this one? All right, well, what's the wire size needed for a two-fold purchase? Okay, oh, well, we got mechanical advantage here. We're lifting. So we got to, first of all, we got to figure out what's the weight that we're lifting. Okay, what weight are we lifting in tons? Okay, we're going to have to figure out that APR again. All right, we're going to have to calculate our C for wire, and then we got to convert to diameter. Okay, so they already told us it was 2.4 tons, so we can just start with that. That's great. We don't have to do any conversion. If they gave it to us in pounds, we'd have to convert to tons. Okay? Now we're going to do our APR. All right, so this is a two-fold purchase. Two-fold purchase has got 2 shivs in the top and 2 shivs in the bottom. It's rigged to advantage. That means we're pulling them from down there. There's no extra blocks in the system. So our shiv number is going to equal 4. That's our friction. And our TMA is going to equal 5. Okay? So now let's do our APR. So APR is going to equal weight times 1 point, whatever the shiv number is, over TMA. So that is equal to the weight. What was the weight? 2.4 tons times 1.1234 shivs over TMA, which was 4 shivs plus we're 2 advantage, so that should be 5. And that's where this whole thing came from right there, okay? That is going to equal to 0.67, okay, tons, okay? So now we're ready to do step 3. Okay, for step 3, we're going to use the wire formula. C equals the square root of L times 2.5. So L is going to be 0.67 tons times 2.5, and you can see that's right there. So my C is going to end up being 1.29 inches, but that's circumference. I need diameter, so now I'm going to do step 4. C equals pi d. I got to divide both sides by pi, and that gives me D equals C over pi, and now I substitute in C was 1.29 inches divided by 3.14 inches. That's what's going on right here. That equals 0.41 inches, which is approximately ½ inch. And that's it.